Hello and welcome to the Arista Cloud Vision Wi-Fi webinar. I am Jatin Parekh and I am the product manager for Arista's Wi-Fi portfolio. Today, I would like to walk you through Arista's Cloud Vision Wi-Fi and the new and exciting features that we are adding to this product. Over the last 20 years, there has been an enormous evolution in enterprise Wi-Fi. Today, you have enormous device density. Each person has up to 5 devices. No devices come with Ethernet connectors today. And Wi-Fi has been running business critical applications. Internet of Things has just exploded the number of devices that need to connect to Wi-Fi. Now, all of these things have delivered huge benefits to the enterprise. Productivity has improved, there has been infrastructure savings and space and energy savings because of Wi-Fi. And the fact that Wi-Fi is so ubiquitous and everybody needs Wi-Fi, whenever there is a problem with connectivity, Wi-Fi is always to be blamed. And yet, it has been verified that over 40% of the time, the cause of the connectivity issues is not Wi-Fi. This is the case where Wi-Fi is guilty until proven innocent. Network administrators have been spending up to 50% of their time chasing these issues which have been reported over Wi-Fi. And it takes at least 30 minutes to address each of these issues. And remember, Wi-Fi is usually innocent. And with the new regime of work from home because of COVID-19, the networks have become more distributed and the administrators need to make sure that home users and users at small offices maintain the same level of Wi-Fi connectivity experience as if they were working out of the office. All of this has put enormous burden on the network administrators. And with Cloud Vision Wi-Fi, we aim to address all of these burdens of the network administrator. We will look at 3 dimensions of Arista's Cloud Vision Wi-Fi today: cognitive Wi-Fi, security, and architecture. Cognitive Wi-Fi provides the tools that are required by the administrator to ensure that Wi-Fi users' experience is pristine, and it helps administrators alleviate the burden of managing, monitoring, and troubleshooting Wi-Fi. Arista's cognitive Wi-Fi has a machine learning artificial intelligence framework that allows it to identify Wi-Fi clients that are failing to connect or Wi-Fi users that are experiencing poor performance or poor quality of experience. It monitors network latencies in real time and continues to hold that data. It allows network administrators to troubleshoot Wi-Fi issues and provides the exact reason for every failure, every poor performance experience. It could be either on the wired side or the wireless side, and it suggests remedial actions to the administrator. Arista's default dashboard, the client journey, displays in a very intuitive fashion the devices that are trying to connect to the network and failures, if any, at each stage of the connectivity process. You can drill down into the list of devices that have failed to know the exact reason for the failure. The next dashboard that is available is the performance dashboard. The performance dashboard tracks the parameters that affect performance over a period of time. It does a baseline of these parameters so that you can drill down to view how these parameters have been behaving over a period of time. And you can also drill down into the list of devices that may be experiencing poor performance because of these parameters. You can also determine if the problem is on the wireless side of the network or the wired side of the network. One key thing that we are adding to this performance dashboard is the single-click RCA. CloudVision Wi-Fi always had the RCA engine, but you had to click through a few screens before you could reach the RCA engine. We have brought this up right onto the performance dashboard so that whenever we see a number of clients having performance issues, you get a single-click drill down into the top locations that may be affected by performance issues, the top root causes of why these performance issues are being seen, and remedial actions to try and resolve the performance issues. To an end user, experience is what matters most. Whenever you are using maybe a VoIP application or a web application, what matters to you the most is what your experience is while using that application. And in today's world, the infrastructure needs to be able to detect user experience, and if there is a problem, provide remedial suggestions for this. Towards this goal, we have the next dashboard called the Application Health Dashboard. What we do here is we monitor in real time the experience that Wi-Fi users have while using certain applications. You can drill down into the list of devices that are using that application and what is the experience of individual devices while using that application. And if there are problems, you could arrive at a root cause of those problems. We are improving the application's health dashboard by extending the number of applications that were being monitored, which were originally 7 VoIP applications, to up to 25 any VoIP or TCP applications that you can choose from over 1,500 applications. So administrators have the freedom to select up to 25 applications that are important to the enterprise and monitor them in real time. Monitor the experience that the Wi-Fi users have while using this application. I also want to point out that with CloudVision Wi-Fi, you can assure the performance of certain applications by using the application firewall rules. You can define a specific DHCP value that should be attached to certain application flows so that as these flows traverse the network, they get the priority that is required. Because so many people are now deploying Wi-Fi, the Wi-Fi spectrum has become really crowded. And to make sure that administrators have a view into this, we are adding a few details onto the access point details page. One of the charts that we have added shows you the channel utilization of the AP's channels over a period of time. You can also view the number of APs that are occupying a particular channel over a period of time. And you could drill down into the RF Explorer that shows you all the APs that the AP under question is able to see, what signal strength is visible from these other access points, and where they lie on the spectrum map across 2.5 and 5 gigahertz bands. One more thing that network administrators need to ensure is network availability at all times, not just on-site, but also at remote and distributed sites. And towards that, we have the active network assurance. We leverage the dedicated multifunction radio available in each Arista AP. We convert this radio into a client, connect to a neighboring AP so that the neighboring AP can be tested. It runs a suite of tests that test connectivity. It tests the responsiveness of the applications that are important to the enterprise and can also do a throughput test. These tests can either be scheduled and the results emailed to specific recipients, or they can be run on demand. The fact that you can schedule these tests at any location means that network administrators from a central location can assure network availability across all deployed sites. Let us now look at the next dimension of CloudVision Wi-Fi: security. Arista's wireless IPS technology takes a fundamentally different approach to WIPs. Traditional WIP systems required that administrators define convoluted rules for rogue AP detection, and the fact that these rules can have mistakes caused way too many false positives and false negatives. This system also needed to be sitting in line and inspecting the traffic to be able to detect exploits and signatures. In contrast, CloudVision Wi-Fi WIPs looks at devices, classifies them into authorized rogue and neighbors devices, and looks for anomalous and threat-posing behavior to detect threats in the Wi-Fi deployment. This allows us to provide protection against zero-day attacks, and the fact that we do not need to sit in line with traffic makes CloudVision Wi-Fi WIPs inherently scalable. One of the key aspects of CloudVision Wi-Fi WIPs is the separation of church and state. Security administrators can define their own policies independently from what network administrators define as the operating parameters for the Wi-Fi deployment. Security administrators can define WIPs profiles, one per SSID, that allows definition of parameters like which frequency band this SSID is supposed to be operating on, what security and authentication framework should be applied to this SSID, down to the level of which VLAN is expected to be carrying traffic for this SSID. APs in the airspace that do not adhere to these policies are flagged. This, coupled with Arista's patented marker packet technology and automatic AP and client classification policies, provide the most accurate classification engine. Devices are classified into authorized devices. These are APs and clients which are expected to be in the enterprise and ones that are deployed by the network administrator. The next classification is rogue access points and rogue devices. These are devices that, while not adhering to the policies that has been laid down, are connected to the enterprise network. And because they are connected to the enterprise network, they are considered to be threat posing. And the next classification is neighbors APs and neighbors devices. These are devices, while obviously not following our policies, are not connected to the enterprise network. And hence, the traffic between these devices should not be disrupted. The fact that we can reliably classify devices into authorized rogue and neighbors provide the confidence that is required for network administrators to turn on automatic prevention and ensure that neighbors' communications are not impacted. We provide an intuitive automatic prevention policy that allows you to define that authorized APs should be allowed to talk to authorized devices. We should ignore traffic between neighbors APs and neighbors devices, and we need to block everything else. The automatic prevention policies allow you to granularly define which of these policies you want to automatically disrupt and which policies you just want to be alerted on. This brings us to the fourth dashboard in CloudVision Wi-Fi, the WIPs dashboard. The WIPs dashboard has an independent device inventory with the classification of the devices, and it has a separate security events list that allows administrators to monitor the security posture of the Wi-Fi deployment. We also integrate with leading NAC solutions like Okta, Forescout, ClearPass, and ICE so that Wi-Fi users connecting to the network get their right authentication and authorization before they're allowed to communicate on the network. Cognitive Wi-Fi and CloudVision Wi-Fi's security provides you a 360-degree view of the Wi-Fi deployment, right from the radio frequency spectrum usage by deployed APs and APs that are visible in the enterprise airspace, to client journey, which lists the devices that are trying to connect to the network and which devices are failing and for what reason, and how many of these are successfully connected to the network. For devices that are already connected to the network, it shows the Wi-Fi user's quality of experience while using applications that are important to the enterprise and provides you a root cause analysis for any problems that may be occurring on the network. And finally, a view into the wireless intrusion protection framework, which shows you the list of devices that are authorized, rogue or threat posing, and neighbors devices, and allowing you to define automatic threat prevention for devices that are threat posing. Supporting cognitive Wi-Fi and the security features that we saw is the modern controllerless architecture of CloudVision Wi-Fi. CloudVision Wi-Fi access points are 100% plug and play and provide an excellent out-of-box experience. You can take an Arista AP out of its box, power it up, connect an Ethernet cable, and it will home in to its management controller either on premises or in the cloud. It will automatically draw down its configuration and provision itself and start operating with the configuration that the administrator has defined for it. As far as the management plane is concerned, we provide flexible deployment options starting from a multi-tenant public cloud, which is deployed on both AWS as well as GCP, to either a hardware or virtualized appliance that can be deployed on premises. For very large customers, we provide an option to deploy a private cloud in the customer's data center. Arista's multi-tenant public cloud is 100% reliable and secure. We are SSAE 18, SOC 2 Type 1 and SOC 2 Type 2 compliant, and we have built-in support for automated high availability and disaster recovery. By doing 24/7 cloud health monitoring, we are able to promise a 99.95 uptime SLA. Even with this highly available public cloud, we provide unparalleled survivability for all sorts of network issues that could cause downtime for Wi-Fi deployments. APs, if they are disconnected from the management plane for whatever reason, they continue to operate with their last known good configuration and provide 100% of its functionality to the Wi-Fi users. Even when you schedule APs for upgrade, each AP times itself in a manner that at least one access point is available to the Wi-Fi users, and thereby Wi-Fi users do not experience any downtime. In case of on-premises deployments, in case of a hardware-based deployment, we provide automatic high availability in a 3-node cluster. And in case of virtualized deployments, we provide an option to configure active standby HA. And as I mentioned, in the cloud, we have automatic backup and disaster recovery. And we deploy this public multi-tenant cloud over GCP and AWS. We have divided the 3 planes, the management, control, and data plane, in a way that only the management plane needs to be centralized to CloudVision Wi-Fi, either on premises or in the cloud. When it comes to the control plane, APs share control information with their own RF neighbors to define a distributed control plane. When new APs join the deployment, they become a part of this distributed control plane. And in case if one of the APs is taken down or goes off for whatever reason, the neighboring APs reconstitute the control plane in a manner that the Wi-Fi users see zero downtime. The fact that this distributed control plane is distributed within the access points and have no dependency on the management plane allows these APs to function with full functionality even if they are disconnected from the management plane. In case of data, on a per SSID basis, we give the option to either break the traffic out onto a local VLAN or tunnel the traffic to an aggregation point, either on premises or across the cloud. We support VXLAN and EOGRE tunnels for this purpose. Arista's modular spline, fixed spline, and campus switches can terminate VXLAN tunnels originating from Arista's access points. CloudVision Wi-Fi is 100% API driven. You can use the pull and push APIs of CloudVision Wi-Fi to extend the functionality of CloudVision Wi-Fi or build your own applications. Even CloudVision Wi-Fi's UI uses the APIs provided for its function. Arista's access points also implement OpenConfig, which allows you to deploy your own management system for a multi-vendor network deployment. Supporting this exciting set of feature functionality is the extensive range of wireless access points from Arista. In addition to the Wi-Fi 5 access points, we are also shipping a full suite of Wi-Fi 6 access points, ranging from the state-of-the-art 12-stream full-function access point to a set of indoor and outdoor APs with internal antennas and external antenna connectors. Very soon, we will come up with a 2x2 Wi-Fi 6 AP for the mass market. We are also working on an exciting family of Wi-Fi 6E access points that will start being available from the end of this year. We are really excited about the Wi-Fi 6E protocol that has been introduced into the market. Wi-Fi 6E opens up 1200 megahertz of new spectrum. New spectrum has been available after almost 18 years. This spectrum is already available in the US, South Korea, and United Kingdom, and partially within Europe, and hoping that the entire band will be opened in Europe very soon. 6 gigahertz clients are already available in the market, and Wi-Fi 6E provides exciting features like continuous spectrum, which will allow us to use very wide channels, less interference because this is a brand new spectrum, and there is no baggage because protocols before Wi-Fi 6 like Wi-Fi 5, Wi-Fi 4, etc. are not allowed to operate in the 6 gigahertz band. So it is reserved for devices running 802.11ax protocol. And this gives us multiple benefits like multi-gigabit link speeds, very low latency, extremely high throughput, and the ability to handle ultra-high density, which has now become a norm because of the IoT explosion. So, in conclusion, today we have walked you through cognitive Wi-Fi, the AI ML-based toolset that allows administrators to provide Wi-Fi users with pristine connectivity experience, wireless IPS that provides the peace of mind to the security and network administrators about the security of their Wi-Fi deployment, and the modern controllerless architecture that underlies the CloudVision Wi-Fi, and it provides the benefits that make CloudVision Wi-Fi the most reliable, scalable, and secure solution that is out there. This brings me to the end of this presentation. Thank you, and we are open for questions.
There is a question, do we have dedicated radios for which functions? I think I have already answered that. Yes, we do have dedicated radio for the which functions in most of our access points. There are mass market access points that do not have this radio, but most enterprise grade access points from Arista has a dedicated radio for multiple purposes, not just WIPs. We also do network assurance, one of the features that we talked about to that. And also serves as a assistant for RRM, so that we don't have to steal cycles from the access radios to ensure that we are aware of all the uh, uh, where the clear channels are, because this multifunction radio is scanning the entire spectrum 24/7. So that releases the burden from the Wi-Fi radios. And there is another question which I'd like to take live here, is that any news on implementing private PSK? So the answer to that is yes, we do have private PSK in the roadmap. The way we are going to address the private PSK is really looking at the IoT use case here. And we will allow up to 64 PSKs to be defined on an SSID. And based on which PSK the device uses to connect to the network, there will be a role that can be assigned to these devices, which could either drop its traffic on on a specific VLAN, or you could have a set of firewall rules that allow the traffic to go to only specific endpoints or servers. So we will be trying sort of a rule to each of these PSKs. So that is on the roadmap, and you would most likely see that before the end of the year. Naveen, there's another question about real life examples of third-party integrations.
Yeah, so as Jatin mentioned, this is the entire architecture is API driven. And just to give you a couple of examples, so we have integration with the NAC vendor ForScout, where in the ForScout, if you configure a set of policies for clients, and if one of the clients is not adhering to the network policy, then through an API call, the ForScout application can block Wi-Fi access to that particular client. So this is one example where you can say a third-party system is able to invoke Arista Wi-Fi APIs to apply a change in, you can say, network by blocking access to a device which is violating the network policy. The other example I would say is where we use streaming of client and access point RSI data, which is fed to a location engine managed by Inner Space, which is used to calculate the position of clients to a high level of accuracy. So this streaming can happen as fast as every 5 seconds, and this is a configurable value. But in terms of you're doing real-time tracking, for example, then this data can be streamed to a third-party server, for example, what is maintained by Inner Space or AeroScout, for example, for locationing purpose. The third use case that I have is where we are using, we built an application called ptracer, which is using the telemetry data gathered by the CloudVision Wi-Fi for proximity detection and mapping the association journey of clients. And the objective here is to assist with contact tracing. So there are many more examples. In the interest of time, I cannot go into details of that. But if anybody has specific questions, they can reach out to me or the Arista team by email.
Hey, then there's one more question around the what do you call it? The wired and wireless issues, the RC engine. And the question is, in order to alleviate wired from wireless issues on the network, if wired connections are not monitored, how do you distinguish wired-related authorized or unauthorized problematic devices?
So I believe the question is related to WIPs, right? So today the root cause analysis engine focuses on the clients which connect over Wi-Fi, right? But at the same time, when a client connects to the Wi-Fi, we look at the KPIs both on the wired side as well as the wireless side, and we are able to at least inform the admin that, for example, if an application performance is not good, then is the reason due to some issue on the wireless link, or the reason may be on the wired link. So this level of distinction we are able to make through this wired wireless RCA. And I see another question on how to use automated troubleshooting and the multifunction radio in the healthcare, etc. So let me take the multifunction radio first. So the way the multifunction radio works is that, as the name says, it does RF scanning, it does wireless detection and WIPS prevention and detection, and it can also do client emulation. So what we mean by that is that you can configure this radio to act as a client and connect to other APs in the network, and then launch a series of tests, which can be connectivity tests, application tests. So it gives you a health check of the network. And this can be done on demand, or you can schedule it so that this test is run, for example, once a day, maybe at the beginning of the day. So you get a report in terms of, which APs are having any issues, and that those issues can be mitigated by the network admin. So that is one part. The second part is with respect to the root cause analysis. So we look at three types of problems. So the first set of problems is related to connectivity, where when a client tries to connect and is not able to do so for reasons maybe related to authentication or maybe DHCP, etc. So we are able to pinpoint the cause of a connection failure. So that is the first step. If the client is able to connect and it can obtain service from the network, then in case it faces any issues related to the RF, for example, the retry rate may be very high, or maybe the latency is high, or maybe throughput is very low. So the system is able to figure out the cause of these issues. So if you have clients, which are not able to function properly, then the system will be able to tell you the root cause of those issues. And the third level is the application level, where when you are using an application, for example, we are having this call over Zoom, and while using the Zoom application, you find out that the quality of experience of particular client or a group of clients is not good, then we are able to look into these issues and figure out what may be the possible cause of the application not working as well as expected. So there's a whole gamut of issues that we are able to handle, from connectivity to RF performance to application performance.
And let me take one more question around how is Okta-based client onboarding different from using things like ICE and ClearPass? So with Okta-based client onboarding, we have two options, right? One which uses a Radius agent from Okta, which you can deploy on premises, and that acts like a normal Radius server. So all of the APs would actually use that Radius server to let the clients authenticate using the Okta credentials. But we also have another mode in which we use our guest manager and perform OAuth-based authentication with Okta. And when you use this OAuth-based authentication, you get SSO with the other enterprise cloud applications that you have tied to Okta. So let's say let me take some examples. Let's say you've got Oracle, Microsoft 360, or Gmail or others, which you are authenticating using Okta. And if you have other devices, other cloud applications that also use Okta, once you log into Wi-Fi, the Wi-Fi device gets an automatic SSO with these devices. So you don't have to re-log into these applications if you have logged into Wi-Fi using your Okta credentials, if you have configured the OAuth-based integration. So, Nadeem, I guess that's all we have in terms of questions today.
Yeah, so last call for anybody who has questions can just type into the Q&A box. So maybe we wait for 1 minute and then we can.
Sure.
So I don't see any more questions, Jatin. So I believe we can close it.
Yeah. All right. Thank you, everyone. It has been, sort of, we've been happy to kind of have you all on this call. And thank you, everyone. And catch you later. Bye.
Goodbye.